Differentiation of inverse sine functions. Leaving cert higher level maths. If y is sine inverse 5x over 3, find dy dx. Firstly, it's important to understand that sine inverse 5x over 3 is an angle. So effectively what we're doing here is we're finding the derivative of the angle y. The formula for doing this is here in yellow, that the derivative of sine inverse x over a is 1 over the square root of a squared minus x squared. So let's look at this example here. We're going to do it in two different methods. The first approach, and the one that's used most often, is to use the chain rule. We're going to treat the 5x as if it is the x in our formula, and our denominator is 3, so that will be our a. And then we'll get the derivative of the inside of 5x at the end and multiply it. So using the formula says it's 1 over the square root of a squared, so that's going to be 3 squared, minus x squared, and we're calling that 5x to be squared. And then we multiply this by the derivative of the inside, which is derivative of 5x is 5. Now this is our solution. We're just going to tidy it up a little bit. So on the top we have 5, that's the square root of 9 minus 25x squared. This approach tends to always work for inverse trigonometric functions. There is a second approach we could take with this example though. We could manipulate the ratio given here so it looks like x over a. Now x being multiplied by 5 over 3 is the same as x being divided by 3 over 5. And now it looks more like the original formula. So x is just x and a is 3 over 5, or 3/5. So we could directly put this into the formula as it is. Let me just neaten this up. So this is the solution, and it's fine like this. However, if you want to get rid of this fraction on the bottom, if you multiply above and below by 5, it'll look like the solution we got using the first method. So these are two approaches you might consider when getting the derivatives of inverse sine functions.